We have seen earlier that RNN is very good in terms of understanding the translation patterns. If it is a very short sentence, I must say that. And we know that machines that are designed to do the translation part is really learning the patterns between two languages and then use that pattern in terms of providing the translation. So, that is the fundamental aspect of any machine learning, right. So, it learns the patterns which are not very clearly visible to us when the size is very huge. Okay. So, in the progression of the machine translation, especially in the neural machine translation, where we just provided in the earlier neural net model an output from the encoder, right. It is an encoded sequence of input sentence, right. So, this encoder gives a small vector which is fed as the input to the decoder, right. So, this is encrypting the entire sentence that has been input into a fixed sized vector, right. This is a fixed size vector that is output from the encoder. Right, and then this goes as input to our decoder, right. And then the decoder output now that we are predicting depends on the context that we have encoded. So, we can call this as the context, right. This context is fed into the decoder and then it is used to predict the next word in during the training process. Okay. So, let me erase this. Okay. So, now what is the next step? So, like we have seen in the statistical machine translation, where we moved from word to word translation to alignment based translation, right. So, we created an alignment model and then using the alignment model later we try to translate the input sentence into a target sentence. And then the same alignment model was extended to phrase based alignment. Instead of just doing a word based alignment, we started aligning phrases, right, between the input and the output sequence. In the same fashion, now we want to extend the neural net based translation also into the alignment based model. Okay. So, how do we do that? So, this is what we are going to be seeing in this particular session. Okay. So, the objective of this attention is to capture the information from the passage tokens that is relevant to the contents of the translation. So, we have a sequence like what we have here, right. And then we want to translate into a target language and then we want to make sure that the information is captured, okay, partially like this. And then use this partial translation or the partial tokens for aiding the translation. Okay. Earlier what we did, we took the entire sentence, is not it. So, we took the entire sentence like this and then oops, we created a context vector, correct. So, instead, so can we not just take part of this and then start aligning that with the target sentence and then see whether the translation would do a better job or not, whether the NMT would do a better job or not. That is what we want to try. Can we know that the different parts of the input have different levels of significance, right. So, this we saw even in the statistical machine translation. So, some parts for example, in the third one different parts of the output may even consider different parts of the input as important. it is not going to be one phrase to the other phrase, one to one kind of a correspondence from in terms of the length. For example, this is not going to be corresponding to the second word in the translation, or rather in the target language, right. So, for example, this particular sequence could be available as part of the target language at the 8th position or 9th position. So, for example, this is in the 3rd position. Let us say if you consider this 1, 2, 3 and 4, right, it is in the 4th position. So, this phrase may be belonging to the 3rd position in the target language. So, we need to figure out how do we really align those how do we really align when different parts align to different parts of the input sentence align to different parts of the output sentence. Okay. So, the idea also is to let the decoder look at relevant portions of the input sentence, which is important to it during that time slice. Okay. For example, if we are in the decoding process during the training. So, what we are doing is at let us say timestamp t, there is a hidden value that we are computing. Okay. So, at that point in time, decoder would like to look at what is there in the input sequence corresponding to that particular time slot, or time t plus 1 slot and so on. You understand what I am saying? See, for example, we have the decoder here and we have the encoder, and then so I am computing this hidden value. Okay. So, it wants to find out which part of this is let us say sentence number 1 of the sequence, and this is word number 1 of that sentence, 2, 3 and so on. Okay. So, this is our y. So, wants to know which part of this sentence of input is useful to me. So, I want this particular node would like to look at or peek into the relevant information encapsulating the passage in the input sequence. Okay. So, I will come to this part again once I finish the last one. Attention mechanism provide the decoder network with the entire input sequence at every decoding step. Okay. So, what it does is at every time slice in the decoder part, it knows what is the entire sequence of input, how is it coded and so on. And then it can look at it and then figure out whether that is useful to it or not. Okay. So, for example, it can take a look at only this portion of the input, or it can only look at this portion of the input and so on, and decide which is important to it and then move along. Okay. So, coming back to the 4th point, right, especially the last part of the sentence, the same as I mentioned earlier in the previous session, RNNs can also be used for question answering. For example, you have let us say we have questions here fed as input, and then we have corresponding answers. Okay. So, this is very useful, especially in the IT services space, where they really service the customer, and then there are a lot of question coming in. It could be used for banks, it could be used for the insurance company, it could be for the healthcare, whatnot, right. So, they have customers, and customers are asking questions, and then you want to find out the right answer for the question that is incoming, correct. So, what you can do is you can actually train on the network based on the corpus of questions and the relevant answers to each of the questions, and train the network. So, the questions can come in various forms. For example, for the same answer there could be variety of questions that are coming in, right. You understand that, right. So, you can phrase the question in several ways, but the answer would be only a single answer for that. All of them mean the same, but they are constructed differently. So, while generating the answer for this, okay, so it can actually look at all the relevant words related to that. It is very similar to what we had seen in the word embedding, right, where we have the skipgram as well as the SIBO model. In the SIBO model, we actually provided the context and we identified the central word, correct. So, in the same fashion, you think of the SIBO model, where the questions are all coming as context questions. The questions are looked at as context words here. Okay. The reason why I am looking at them as the context word is, in the case of the SIBO, we are able to really relate the central word with the set of context words. In the same fashion, we can relate the answer with the set of contextual questions. The neural nets are really good in terms of understanding the context, understanding the pattern, so that when in the next production cycle, when a question of that type, need not be same as what it had seen comes in based on the contextual words, it would be able to predict the answer. Okay, so, we can use the set of RNNs, one for encoding the question and another one for answering the question that are coming in into the encoder here. Okay, so that is where this is going to be useful. Okay, all right. So, we have seen this fifth one as well, right. Okay, so, moving on to the next one. So, what happens when we do the training process? When we try to peek in from the decoder into the encoder, the attention based model learns to assign different parts of the input for each step of the output. So, it is able to really assign, say for example, this portion of the target is aligned to this portion. Since it keeps looking at the patterns, when you provide close to about 500 million pairs of sentences, it captures those patterns and is able to really relate those very clearly. In the context of the translation here, the attention can be thought of as alignment. It is very similar to what we saw in the statistical machine translation, where we used alignment, and here we are going to be using the term attention. Okay. Bahdanau and others, they actually are the creators of this attention based model. So, this is a seminal paper. You may want to read this paper. Okay. They claim that the attention is automatically learnt when you are able to provide the attention mechanism in the neural net. So, let us look at the details of that little later. Okay. We can also use the attention score to build the alignment table. So, here the alignments are not pre-computed, it is learnt along the training process as well. Okay. So, we know that it is a table of mapping of words in the source to corresponding words in the target sentence. Okay. So, automatically this particular model learns as well as align the sentences on its own. So, there is no separate module for creating the attention.